Okay, so let's go through some examples now of simulations. So suppose we wanted to simulate the roll of a six-sided die. The numbers are going to be 1, 2, 3, 4, 5, and 6. Okay, so if we're going to do this, this is an example of where we only have consecutive integer outcomes. So based on the procedure we said before, you would start by identifying what your A and your B are, right? So your A here is 1, that's the smallest of the numbers. And your B minus 1 is going to be 6. That's the largest of the numbers. So if B minus 1 is 6, that means B has to be 7, right? 7 minus 1 is 6. So what we'll do then is we'll multiply math.random by 7 minus 1, or 6, which was the number of possible outcomes here. Okay, so 6 times math.random is now going to produce a number from 0 to 6, right? If math.random produced 0, you would get 6 times 0 is 0. And if math.random produced 1, you would get 6 times 1 is 6, right? So the next step would be to add our A, right? Our A is the lowest integer you can get. That's 1 here. So we add 1, and we get 6 times math.random plus 1, which is now going to produce a random number, or a pseudo-random number from 1 to 7, right? If it 6 times math.random produced 0, then by adding 1 we would get 1. If it produced 6, by adding 1 we would get 7. Okay, but this can produce any number from 1 to 7, so it doesn't necessarily have to be a whole number. So the next step was to do math.floor of this, which is going to round it down, right? So if it's between 1 and 2, right, you would get 1. Not including 2. If it's between 2 and 3, not including 3, you get 2. If it's between 3 and 4, not including 4, you get 3, etc., right? And you can't get 7 exactly, so any number between 6 and 7 would go down to 6, right? So this gives us the simulation of the 6 possibilities that we can get from the die. So now the question was to write a Boolean expression that'll be true when the roll is a 1 or a 2. So we want to know that this expression that we have here, this math.floor of 6 times math.random plus 1, we want to know that it's less than or equal to 2, right? That would correspond to getting a 1 or a 2, and the probability of this is 2/6 or 1/3, which is approximately 0.3333, right? It's 0.3 repeating. So if you were to run this, test this out a large number of times, you should get it roughly 1/3 of the time. Okay, so this is the correct solution. Let me tell you what a wrong solution would be. So a wrong solution would be to basically repeat this 2 times. So you have math.floor of 6 times math.random plus 1 equals 1, right? Or math.floor of 6 times math.random plus 1 is equal to 2. So this is really simulating the roll of 2 dice, and it's asking if the first one is 1 or the second one is 2. And if we consider all of the 36 possibilities, you'll see that this will be true for 11 of them, right? So in order to actually have the same probability as the correct answer, it would have to be 12, because then it would be 12 over 36, which is the 1/3 we got before. But you could see this overlapping case here. We have 6 here and 6 here, but there's an overlap of 1. So it's actually only going to be 11 out of the 36 possibilities, and the probability would be 0.3056 approximately. So this would be the wrong way to do it and would not actually give you the same probability. Okay, so another example we can talk about is flipping 3 coins, and we want to see if you come up with 2 tails. So the way we'll model this experiment is, first of all, coin has 2 equally likely possibilities, so we're going to use 0 for heads and 1 for tails, right? So this time we want an integer that's between 0 and 1. So again, we have our A of 0, B minus 1 is 1 this time, which means B is 2. So using the same procedure that we did before, this time we multiply math.random by 2. 2 minus 0, that's your B minus A. This is also the number of possibilities you have. So 2 times math.random is going to produce a pseudo-random number from 0 to 2, right? If math.random produces 0, then multiplying by 2 gives you 0. If it's 1, multiplying by 2 gives you 2. Right? The next step would be to add what a is here, but a is 0, so it's not going to actually change the result from before, right? We would still get a number from 0 to 2. So you can put plus 0 here, but it's unnecessary. Any number you add with 0, you're just going to get back that number, right? And the last step is, as before, to do math.floor of this. Right, so this actually simulates the flipping of one coin, but we wanted to do 3 coins. So this time what we're doing is math.floor of 2 times math.random 3 times. And we'll add all of these together and see if it's exactly 2, right? Because if a tails is 1 and heads is 0, and we have exactly 2 tails and 1 heads, right, we should get 1 plus 1 plus 0, or 1 plus 0 plus 1, or 0 plus 1, or 0 plus 1 plus 1, right? So one of those possibilities, all of them would have a sum of 2, right? So this would give you your probability of 3/8, which would be 0.375. Now let me point out that you could have also said it equals 1 here, if you had said that 1 was heads and 0 was tails, because in that case you would have 2 zeros and 1 1 that would sum up to 1. So regardless of how you, regardless of whether you ask if this is equal to 1 or equal to 2, you should get roughly the same number of times that is actually evaluates to true, which should be about 3/8 of the time. And this again shows that there are many different ways of modeling the same experiment here, or the same simulation. So the last 2 examples here were just simulating rain versus no rain, right? So here we have to say what's the probability that it will rain. So let's just assume it's 0.15, right? So here, if we're actually trying to simulate rain to see if it rains or doesn't rain, remember that if you ask if math.random is less than 0.15, it's just going to be, that means it has to be between 0 and 0.15, which is going to happen about 15% of the time, 0.15, because math.random produces a number between 0 and 1. So this will give you your answer right here. So it's pretty simple like this. I should mention that you could also use less than or equal to, because the probability of getting 0.15 exactly, as I said, theoretically it would be 0. From a practical standpoint, it would just be extremely small. So it's basically impossible to get, and so it really won't affect the percentage of the time that this actually happens. Okay, so if we wanted to know the probability that it doesn't rain when the probability of rain is 0.15, what we're really saying is it's not the case that math.random is less than 0.15, right? That was the math.random being less than 0.15 was simulating the actual chance of getting rain. So to not get rain would be not of that. And so we could also write math.random, which I should have 2 parentheses there, is greater than or equal to 0.15, right? And if we had used less than or equal to over here, right, we should use greater than, right? Because if it's not less than or equal to, it's greater than. But again, this won't matter for the output, right? So another way you could have actually simulated this was, again, putting the 2 parentheses here, math.random is less than 0.85 or less than or equal to 0.85, because the probability of no rain would be 1 minus the probability of rain, which would be 0.85. So regardless of how you do it, all of these answers would be correct. So one final thing I want to point out is that after you have come up with the conclusion of what it should be, you should always test your answers. So if you go to this link, you can run the code. This is going to run the experiment approximately, well, it's going to run the experiment exactly 100,000 times. each of these answers that we talked about. And again, this is going to be the code to actually determine the percentage of the time that the expression here that you put, right, as part of this Boolean function, Boolean valued function, is true. So whatever number of times out of 100,000, it's just going to divide that by 100,000, and that will be that should be the approximate. That should be an approximate to the true probability of what it is. So again, you can check your answers here, and you should in general. Okay, so that's it.